Chevron is announcing a break with convention, giving you even more reasons to choose Delo. Today we're back to talk about motor oil, but this time we're going to talk about viscosities. More specifically, what are viscosities? Like, I know it has to do with thickness of oil, but what does that mean for my engine and why are viscosities changing? Today we're joined by Kevin with Chevron, and he's going to talk to us more about what all of this means. Well, Kevin, thank you so much for being back on the dirt. It's good to see you again.
Yeah, great to be here. Thank you for inviting me. I appreciate it.
Yeah, absolutely. So my first question is, when we talk about viscosities, you know, on this side, on the front lines, is people who don't really know a whole lot about oils. We talk about, 10W30, 15W40. What are we actually talking about there? What is viscosity?
Yeah, it's a good question. And rather than getting into sort of a deep scientific description of it, let's try to connect it to the reality that people experience. Viscosity is a measure of a fluid's resistance to flow.
Okay.
Is kind of one way to think about it. So we know that water flows easily, and so we say water has extremely low viscosity. Honey, on the other hand, takes a little bit of effort to get it to flow and has a very high viscosity. So the viscosity of the fluid is there to keep moving surfaces apart, and that's probably the most important consideration to avoid friction and wear in an engine. And in an engine, you've got different conditions. Temperature, we know temperature affects viscosity. So if an engine oil that is as thick as honey at minus 20 degrees Fahrenheit will be almost as thin as water at 300 degrees Fahrenheit. So the viscosity of the oil changes with temperature. And there's another condition that we call shear. And you intuitively know what shear is. If you think of the narrow passages in an engine, like between bearings and shafts, that's a high shear environment. It takes a lot of work to force the oil through those orifices and narrow gaps. So that's a high shear environment. A low shear environment is maybe the oil just flowing through the oil galleries, right? There's still some shear going on, but it's pretty low. So that's kind of how I think of oil, and just kind of tying that back, the important thing to keep in mind is you want the right viscosity at the right conditions.
So why are oils listed with two viscosities versus like an SAE 30 or whatever? Why is there only one viscosity there, but in a lot of our engine oils we have two viscosities listed?
So that's a system that was put in place to enable people to make intelligent buying decisions. And it's a good system. And there's two numbers that people generally see. You'll describe it as like a 15W40. So the 15W would be the first number, and that tells you the winter grade. It's a good way to remember it. And lower numbers will tell you that the oil is suitable for use in very cold weather. So these oils have been checked performance-wise to make sure that you can start and lubricate your engine. And a 15W is good down to about 4 degrees below 0 Fahrenheit. A 10W runs down to minus 13, a 5W minus 22, and a 0W minus 31 degrees Fahrenheit.
Okay.
That's what that's telling you. And even in Wisconsin, minus 30 degrees Fahrenheit is pretty cold. And so 0Ws are for those really cold conditions, 15Ws are for the warmer conditions. The second number is a 30 or a 40 in most heavy-duty service, but there's other numbers now that you may not be aware of. There's 20 weights, and there's now even 8 weights and 16 weights. These are really thin oils.
Interesting.
Yeah, and so the second number tells you how the oil flows in a hot engine. So a higher number will give you a thicker oil film. Lower numbers mean that the oil is easier to pump. And of course, that pump takes work to push the oil through those narrow galleries. So a more viscous oil takes more work, and it uses up more fuel. It's small, right? 1%, 2%, something like that. But a 1030 saves you about 1.2% over 15W40 is kind of a round number. So the way to think of it, higher numbers, hotter temperatures, lower numbers, colder temperatures. That's kind of the way to think about it.
Gotcha. That makes total sense. Now, I guess for a consumer on this end of it, why do I care about viscosity? What impact does that have? Why not just throw a 10W30 in any engine? Why do I need to worry about the differences in viscosity? But before we get into that, I want to take a second to tell you about the sponsor of this video, Chevron Lubricants. These past few years have been less than easy. We've encountered challenges we never imagined we'd ever have to deal with. From makeshift home offices and video meetings, to global supply chain uncertainty, price instability, market disruptions, and everything in between. Delivering the level of services and products our customers had come to expect was difficult for all of us. We can't change what's behind us, but we can definitely learn from it. We can adapt, evolve, and take steps to reset our thinking, adapt our strategies, and restore your trust in us to better meet your needs, now and in the future. That change begins today. Today we break with convention and introduce a rebalanced line of Dello heavy-duty engine oils. We've reduced our product line from 4 categories to 2. Consolidated and simplified, this lineup removes complexity from the manufacturing processes, enhancing price stability and supply chain reliability, so you can trust you will have the premium products you need to keep your business always moving forward. Our break with convention optimizes the Dello lineup to allow you to provide your customers with the best synthetic blend and synthetic heavy-duty engine oils in the market, fully available at prices you can rely on. It's your assurance that you'll be well positioned to be their trusted source for proven engine protection that keeps equipment on the job, giving your customers even more reasons to choose Dello. Why do I care about viscosity? What impact does that have? Why not just throw a 10W30 in any engine? Why do I need to worry about the differences in viscosity?
Well, the purpose of a lubricant is to control friction and wear, and it's important to match the right viscosity to the equipment and its use. Thicker oils are going to give you a heavier oil film when the oil is hot, but a lot of wear happens when you cold start equipment, and a somewhat thinner oil like a 1030 is going to flow through the engine more quickly than a 1540 will when cold, and so you will actually get less wear with a thinner oil if you have a lot of cold starts. It's kind of counterintuitive. The thicker oil, when it's cold, won't get to where it's needed. My mantra is you want to match the viscosity to the application, right? Heavy duty pushes the limits on engine oils. Oxidation, nitration, wear, corrosion, heavy duty service is hard on engine oils. Older equipment was designed for fuels and engine oils of the day, but things have changed. We've talked about this before. Since 2010, we've taken most of the sulfur out of diesel fuel. That reduces corrosion and oil degradation. And now most OEMs factory fill with 1030. And at least one OEM uses an FA4 5W30 as a factory fill oil. Oil pumps are a lot better now. Oil pumps are a lot more efficient. They take less power. They heat the oil less. And oil pumps can now dynamically match the flow and the load to the conditions the equipment is under. Some engines can even turn on or off the cooling jets used to spray pistons. My point is, engines are a lot more sophisticated now. And so to take advantage of fuel economy and other benefits, newer engines can use lighter oils than you've traditionally been used to, and there is no wear penalty. They're engineered and designed for these lighter oils.
Interesting. So that actually is a perfect segue into my next question, which is, why is it that diesel engines traditionally have used the heavier, thicker oils, and what is now kind of allowing us to transition to thinner oils?
It's all around the design. You're going to see with the next category that's coming up, actually the preference of heavy-duty OEM engine builders these days is 10W30.
Interesting.
And you're going to see even lower viscosity oils. 5Ws are going to become more common. In actual fact, I believe, probably want to talk to an engine builder, that might be hard to do, but I think these engines are going to run better on 1030s than 1540s. And I know at least a couple of OEMs are considering not even allowing 1540s in some markets. In the U.S., they will allow 1540s, so I'm not trying to start a panic or anything.
Sure.
But in some markets, the expectation is people are just going to abandon 1540s for brand new PC-12 kind of equipment. This is a few years from now. This isn't happening right away. But the whole emphasis is on reducing fuel consumption.
Interesting. So what has allowed the coming down on the viscosities? Why haven't we traditionally been able to do that?
I think the expectation that most people have is a thicker oil gives you better wear protection. And that's true under most conditions, but a lot of wear happens when an engine is cold. And with the newer high-pressure oil pumps that can match performance to the conditions, an oil film can be provided that works just fine even with a lower viscosity oil. You don't need heavier oil to have that protective oil film.
That's fascinating. The more I have said it before, but the more I talk to you guys and learn about kind of all of the inner workings behind the scenes of what goes into a motor oil, it's just, I continue to be fascinated at the technology and the development and just the evolution of these oils as they've come along. This is really interesting stuff.
Things are changing. They're changing faster than most of us realize.
Yeah. Well, Kevin, thank you again for the time. This has been super helpful. I appreciate it. Well, thank you again for Kevin coming on the show to educate us more on how viscosities impact our engines, the performance, and more importantly, why are these viscosities changing over time? As always, I hope this helps you in your business. We'll catch you on the next episode of The Dirt.